Hello everyone, welcome to another session where we'll be discussing JEST PYQs of quantum mechanics, right? So let's try the first question. First question is the operator dy dx minus x dy dx plus x, okay, is is equivalent to dash. Okay, option A d square by dx square minus x square. Option B d square by dx square minus x square plus 1. Option C d square by dx square minus x dy dx of x square plus 1. Option D d square by dx square minus 2x dy dx minus x square. Okay, so the operator this and into this is equivalent to dash. So this came in a JEST 2059. Okay, so how to solve this question? See, what will you do? So d by dx minus x dy dx plus x whole into psi. Okay, we have to, when we are calculating the value of an operator, we have to put an eigenfunction of psi here, right? We have to put that psi here. So that will be, you have to now operate psi first, operate this one on psi. So dy dx of dy dx minus x whole into d psi by dx plus x psi. Okay, d psi by dx plus x psi. This becomes d. Now I have to multiply this d square psi by dx square plus dy dx of x psi minus, wait, minus x d psi by dx minus x dx by dx minus x square psi. Alright? Yeah? Is that alright? Now what? Now see, um, I will open this one. D square psi by dx square plus x d psi by dx plus psi dx by dx minus x d psi by dx minus x square psi. So see, this will be cancelled out. So d square psi by dx square plus psi dy dx dx by dx is 1 minus x square psi. So if you see, if I take out the psi, so d square by dx square minus x plus 1 whole into psi. So the in the left side, what was the operator dy dx minus x whole into dy dx plus x psi. So we can cancel psi out, right? So this will give me dy dx minus x dy dx plus x is equal to d square by dx square minus x plus 1. Is that alright? So this will be the answer. This will be the option B. Yeah, option B will be the answer. Is that alright? Yeah. Okay. Next question. Question number 2. What are the eigenvalues? What are the eigenvalues of the operator? The operator H is equal to sigma dot A, where sigma are the three Pauli matrices. The three Pauli matrices, and A is a vector. A is a vector. Ax plus Ay and Az should be Ax plus Az plus or minus Iay should be plus or minus Ax plus Ay plus Az. Option D, plus or minus A. Okay. What are the eigenvalues of the operator H is equal to sigma dot A, where sigma are the three Pauli matrices and A is a vector. Okay. So your answer is C. H is equal to how much? So H is equal to sigma is what? I can get sigma x Ax plus sigma y Ay plus sigma z Az, right? Sigma x is how much? Now sigma x is 0, 1, 1, 0. Sigma y is 0 minus I 0. Sigma z is 1, 0, 0, minus 1. Just put them 0, 1, 1, 0 Ax plus 0 minus I 0 Ay plus 1, 0, 0, minus 1 Az. Alright. So now we just have to open them and we will see this is Az Ax minus Iay. This is your Ax plus Iay. This is minus Az. Okay, this is your H. What is the question? Question is what are the eigenvalues of the operator H? So eigenvalues, for calculating eigenvalues, what do? We like H minus lambda I is equal to 0, where I is the unit operator. So so it will become Az minus lambda Ax plus Iy. So this was a minus Ax plus Iy minus Az minus lambda 0. Yeah. So Az minus lambda minus Az minus lambda minus Ax minus Iy whole into Ax plus Iy is equal to 0. So this gives me minus of Az minus lambda, Az plus lambda minus, this will give me Ax square minus minus plus Ay square bracket is equal to 0. So this becomes Az square minus lambda square minus Ax square minus Ay square is equal to 0. So this gives me minus Az square plus lambda square minus Ax square minus Ay square is equal to 0. So lambda square is equal to everything goes to that side. Ax square plus Ay square plus Az square. Now tell me, A vector is what? Ax I cap plus Ay j cap plus Az k cap. So A square will be what? We know Ax square plus Ay square plus Az square. So lambda will be plus or minus Ax square plus Ay square plus Az square. Is that alright? Yeah. So I can write it as also lambda is equal to plus or minus A vector magnitude. Yeah. So this is your eigenvalue. This is option D. Okay. Option D. Okay, next question. Question number 3. If Jx, Jy, and Jz are angular momentum operators, the eigenvalues of the operator eigenvalues of the operator Jx plus Jy by h cut are option A real and discrete with rational spacing, option B real and discrete with irrational spacing, option C real and continuous, option D not all real. Jx, Jy, Jz are the angular momentum operators. The eigenvalues of the operator Jx plus Jy by h cut are real and discrete with rational spacing, real and discrete with irrational spacing, real and continuous and not real at all. Try this question. Try this question. See, Jx, Jy, Jz are angular momentum operator. We know what? We know Jx is equal to how much? Half J plus J minus. But Jy is 1 by 2y J plus minus J minus. Isn't that right? Yeah? Is it correct? Hmm. So, uh, we can also write Jx as what? Okay, we know J plus is h cut 0 1 0 0. Okay. J minus is how much? H cut 0 0 1 0. Hmm. Yeah. So your Jx becomes how much? 1 by 2 h cut by 2 0 1 1 0. Using this, Jy becomes how much? 1 by what? H cut by how much it becomes? H cut by 2I 0. This will be subtracted. Minus 1. 0 1. Minus 1 0. Yeah, like this. 0 1 minus 1 0. Jy, if I write again, h cut by 2I 0 1 minus 1 0. See, I will do one thing. I will take the I to upside. The numerator it will become what? Minus I h cut by 2. 0 1 minus 1 0. If I take the minus inside, it will become I h cut by 2. 0 minus 1 1 0. Yeah, this is your Jy. This is your Jx. This is your Jy. What is the question? Jx plus Jy by h. So let's do it. So Jx plus by how much? By h cut, sorry. By h cross. Jx is how much? H cross by 2, 0 1 1 0 plus Jy how much? I h cross by 2, 0 minus 1 1 0 whole divided by h cross. This gives me h cross cancelled out 1 by 2, 0 1 1 0 plus I by 2, 0 minus 1 I 0 1 0. So 0 minus 1 1 0. Now if I add them, it will be 1 by 2, 0 1 minus I. This is 1 plus I 0. Okay. What is the question? Question is eigenvalues of the operator. This is the operator. We found the operator. This is the operator actually. So we need to find the eigenvalue. How will you find the eigenvalue? Half 0 minus lambda 1 minus I 1 plus I 0 plus lambda 0. Yeah. So if you see, this is a lambda square minus 1 minus I into 1 plus I is equal to 0. Is equal to minus lambda square minus 1 minus I square is equal to 0. Minus lambda square minus 1 plus I square is minus 1. Minus 1 is equal to 0. Lambda square is equal to how much? 2. Yeah, isn't it? Or did I do any mistake? Yeah, 2. So lambda is equal to plus or minus root 2. Okay. Lambda will be your plus or minus root. Okay, I did a mistake. Let's see. This is lambda not minus. Why is it plus? Minus lambda plus lambda square. So this is correct now. Lambda is equal to 0 plus or minus 2. That means 2 root 2 minus root 2. Okay. What is the spacing between root 2 and minus root 2? Because the question is what? The eigenvalues of are first of all are what? Are real. These are real, isn't it? These are real. First of all, real. So real are the options. Option D is cancelled out. That not all real. The real and discrete with rational spacing. Is it rational? What is the spacing between them? Root 2 minus root 2. Root 2 plus root. Spacing in between means gap. 2 root 2. So 2 root 2 is the gap between them. 2 root 2 is a what? It's an irrational number. It's not a rational number. Root 2 is an irrational number. So 2 root 2 is also irrational number. So real and discrete with irrational space. Discrete. It's not continuous. Discrete. Got it? Clear? Yeah. So this was the answer to this question. I hope you. I hope it's clear for you. Next question I done. It's a good one. So for the expectation value, the expectation value of the momentum is P for the wave function for the wave function psi x, then the expectation value, then the expectation value of momentum for the wave function e to the power I k x by h cut psi x is option A k, option B p minus k, option C p plus k, option D. The expectation value of the momentum is p for the wave function psi x. Then the expectation value of momentum for the wave function e to the power I k x by h cut psi x. Expectation value of momentum is p for the wave function psi x. Then the expectation value of momentum for the wave function e to the power I k x by h cut psi x is. Try this question for 2 minutes. Okay, did you try this? See, first of all, momentum, expectation value momentum, how will I write it? Integration minus infinity to infinity sine star x, okay, p psi x dx. That can be written as minus infinity to infinity sine star x. P can be written as minus h cut del by del x of psi x dx. Yeah, is that right? So I can take minus I h cut out. So minus I h cut minus infinity to infinity sine star x del by del x of psi x dx. Yeah, is that all right? Huh? So now, then the expression value momentum for the wave function this. Now the wave function is this one. So, but this one we know now is your p. Okay. So what is the new wave function? New wave function e to the power I k x by h cut psi x. So we have to find for this one. Let's do it. So p dash, suppose p dash minus infinity to infinity again psi star x minus I h cut del by del x of e to the power I k x by h cut psi x. Isn't that right? Dx. Okay. So what I have to do here? I'll do it separately, isn't it? Because these are two quantities, so take the derivative. First, let's take the minus I h cut out. Minus I h cut minus infinity to infinity psi star x del by del x of e to the power I k x by h cut psi x dx. Alright. So minus I h cut uh, minus infinity to infinity. See psi star x. First d by del by del x of e to the power I k x, then I k x into psi x dx plus minus infinity to infinity sin star x. Then e to the power I k x will be out and del by del x of psi x. Simple basic derivative. Okay, dx. D by dx of u into v. Okay, I put that formula here. So minus I h cut minus infinity to infinity. I k x is I k, right? Psi star x e to the power I k x psi x dx. Okay, plus minus infinity to infinity. Okay, e to the power I k x psi star x psi star x del by del x of psi x dx. Is that right? Is that right? Hmm. Yeah. Am I missing something? Okay, I k x by h cut is there. Huh? So I k by h cut. Okay. Now what? Now what? Now how am I gonna solve it? Okay, see. One thing, another mistake I have done here. So the expectation value here, see this one, na, if this is psi x, then psi star x will be what? E to the power minus I k x by h cut, right? This should be here, e to the minus I k x by h cut. E to the minus I k x by h cut. E to the minus I k x by h cut. Psi star x, right? So this is actually wrong. I have made a mistake. Okay, because see the wave function, new wave function is what? E to the power I k x by h cut psi x. So psi star part will be what? E to the minus I k x by h cut, the conjugate of it. I just wrote psi star x only, so that was the mistake. Okay, let me do it again. P dash minus infinity to infinity e to the power minus ikx by h cut psi star x. Then you can write it here as, what is the middle part? Minus ih cut del by del x of e to the power ikx by h cut psi x dx. Hmm. So that will be minus ih cut goes out, minus infinity to infinity e to the power minus ikx by h cut psi star x del by del x. This one will be how much? Ik by h cut e to the power ikx by h cut psi x dx plus minus infinity to infinity e to the minus ikx by h cut psi star x e to the power ikx by h cut del psi by del x. Okay, dx. This was the whole thing. Now if you see this e to the power ikx, these are minus ikx would be like 1, right? I minus I plus I, that will be 1. So like 0, the power will be 0, I e to the power 0 is 1. So this will become, and this one I can take ik by h cut out, and again minus infinity to infinity it's on minus ikx by h cut psi star x into e to the power ikx by h cut psi x dx. Okay, and plus minus infinity to infinity here. These two are giving me 1, so only psi star x left. Psi star x del by del x of psi x dx. Is that right? Now these two will also be cancelled out, giving me 1. So minus ih cut ik by h cut minus infinity to infinity psi star x psi x dx. Yeah, plus minus infinity to infinity psi star x del by del x of psi x dx. See how simplified it is now. Now if you remember, this term is actually what? Yeah, see, same term. So this is your p, isn't it? So that is your p minus ih cut. Minus ih cut into this is actually p, like expectation value of p. So I can write it here. See, I will just multiply now. Minus ih cut into ih cut by k. So, ik by h cut, sorry. Ik by h cut minus infinity to infinity psi star x psi x dx. Okay. Minus ih cut minus infinity to infinity psi star x del by del x of psi x dx. So this is your p expectation value. If you see, this is your 1, isn't it? Because this is like psi star into psi dx, the integration is 1. So minus into minus I into a is 1. H is cancelled out. K. So this is k, right? And this is your what? P. Got it? So p star is equal to how much? Or p dash is equal to how much? P dash is equal to p plus k. Is it clear? I hope you understood. It's not hard, but it's a bit lengthy, and you have to be really careful with the negative, positive signs. Okay, that is the answer. Okay, so question number 4, question number 5. Now suppose a spin half particle is in the state is in the state psi is equal to 1 by root 6 1 plus I 2. Okay. If Sx x is the x component of spin angular momentum operator, okay, is measured is measured, then what is the what is the probability of getting plus h cross by 2? What is the probability of getting plus h cross by 2? Suppose a spinner particle is in the state psi is equal to 1 by root 6 1 plus I 2. If Sx is measured, then what is the probability of getting plus h cut by 2? Okay. See what is given. Psi is given 1 by root 6 1 plus I and 2. Okay. Yeah. So if you see your Sx is what? H cross by 2 0 1 1 0. Okay. And the eigenvector and its eigenvalues are what? Eigenvalues are plus or minus h cross by 2. But the eigenvector corresponding to h cross by 2 is how much? Plus h cross by 2. Because we need plus h cross by 2. So the corresponding to eigenvalue plus h cross by 2 is how much? This is your 1 by root 2 1 1. Okay, this is the eigenvector. You have to remember this. So now easily you can calculate probability of getting plus h cut by 2 will be how much? T is equal to phi psi square. Phi is your this one. Okay. So 1 by root 2 1 1 into the one that we need 1 by root 6. This is the question. 1 by root 6 1 plus I and 2 and their square. So if you do it, this will be 1 by root 12 and this will be 1 plus I plus 2 and whole square. That will be 1 by 12 into this will be how much? 3 plus I square will be 10. Okay. So 10 by 12, that is 5 by 6. So probability will be how much? Probability will be 5 by 6. So probability of plus h cut by 2 is 5 by 6. So probability of minus h cut by 2 is how much? 1 by 6. Because total probability should be 1, right? Next question for the question number 5, question number 6. Question number 6. The lowest quantum mechanical energy of a particle confined in a 1D box of size L is 2 electron volt. The energy of the quantum mechanical ground state for for a system of for a system of three non-interacting non-interacting spin-half particles, is the lowest quantum mechanical energy of a particle confined in a 1D box of size L is 2 eV. The energy of the quantum mechanical ground state for a system of three non-interacting spin-half particles is 6 electron volt, 10 electron volt, 12 electron volt, and 16 electron volt. 6 electron volt, 10 electron volt, 12 electron volt, and 16 electron volt. Okay. Lowest quantum mechanical energy of a particle confined in a 1D box of size L is 2 electron volt. The energy of the quantum mechanical ground state for a system of three non-interacting spin-half particles of a particle 1D box of size L is 2 electron. So this is lowest quantum mechanical energy. That means this is the ground state energy. Ground state energy is 2 eV. Energy of the quantum mechanical ground state for a system three non-interacting spin-half particles. Okay. So ground state energy E1 pi square h cut square by 2 ml square is equal to 2 electron volt. Yeah. Yeah. What is the question? Ground state for a system of three non-interact particles. Your E2 is how much? 4 pi square h cut square by 2 ml square. So that will be 4 into, so that will be 8 electron volt. Yeah. Hmm. So the energy of the quantum mechanical system for a system of three non-interacting spin-half particles. So see, particles are three now, three particles. Spin-half. Spin-half means what will be the multiplicity? 2s plus 1. That means 2 into half plus 1. That is 2. So two particles can be in one state, right? So total three particles. So two in the first and one in the second, right? So 2 into pi square h cut square by 2 ms square, 1 into this one is how much? 4 pi square h cut square by 2 ml square, ml square. That will be the total energy. So E total will be 2 pi square h cut square by 2 ml square plus 4 pi square h cut square by 2 ml square. That will be 6 pi square h cut square by 2 ml square. Right? Right? Which is what? We know pi square h cut square by 2 ml square is 2 electron volt. So 6 will be 6 into 6 into 2 electron volt. That is 2 electron volt. This will be your energy. Okay? This will be your energy. Is it clear? Is it clear? I hope it's clear. Okay? Question number 7. Question number 7. A spin-half particle. Spin-half particle in a uniform external magnetic field has energy eigenstates 1 and 2. Okay? The system is prepared. The system is prepared in Kate state. Kate state 1 plus 2 by root 2. At time t is equal to 0. Time t is equal to 0. It evolves to the state. It evolves to the state. It evolves to the state described by the Kate. Described by the Kate. 1 minus 2 by root 2 in time t. In time t, capital T. The minimum energy difference, the minimum energy difference, the minimum energy difference between two levels is two levels is minimum energy difference between two levels is option A h by 6t capital T, option B h by 4t, option C h by 2t, option D h by t. Okay, these are the options. Read the question two times. Spin a particle in a uniform external magnetic field as energy eigenstate 1 and 2. The system is prepared in kth state at t is equal to 0. It evolves to the state described by the kth in time t. The minimum energy difference between the two levels is. Okay, spin a particle in uniform magnetic field. So, if I do the solution, see your psi at t is equal to 0 is how much? 1, 1 plus 2 by root 2. Okay. So psi at time t will be how much? Psi at time t will be 1 into uh, e to the power minus I e1 t by h cut. Okay. Plus 2 e to the power minus I t2 by h cut. Right? Is that right? Yeah. By root 2. We know this is the time evolution of a wave function. Right? So what is the question? It evolves to the state this. So the state actually that it obtains is it's in negative. Like the state is actually like this, isn't it? Right. So this is your 1 e to the minus e1 t by h cut plus 2 e to the power minus e2 t by h cut whole divided by root 2. Root 2 cancelled out. Okay. So if you see, I will take it common. So 1 minus is equal to what did I do here? A to the power mm, minus I e1 minus e2. Okay, see. What will be 1 plus 2 e to the power. I will take this as common here. Minus I e2 minus e1 t h cut. Okay. Yeah. So now if you actually see the coefficient of 1 is actually 1. So 1 cancel out. So coefficient of 2 is actually how much here? Minus 1. So I can equate this whole thing to minus 1, isn't it? Right. So I will equate it. This 1 t by h cut is equal to minus 1. Right. Is it here? Yeah, is it here? So minus 1 we know. Minus 1 can be written as cos pi plus I sin pi. See, sin pi is 0, so cos pi is minus 1. It can be written as e to the power I pi. Cos theta plus I sin theta is e to I theta. So e to the power minus I e2 minus e1 t by h squared is equal to e to the power I pi. So we'll just exponents, we will equate the exponents. So minus I e to the minus t by h squared is equal to I pi. So I cancelled out. Now this one I can write a e minus e2 h squared by 2 can go to that side h squared pi by t. But we need t, right? So t is equal to h squared pi by e1 minus e2. Okay, e1 minus e2. So what is it? Oh, what is the question again? Let's see. The energy difference. Okay, energy difference is asked. So e1 minus e2 we have to find. It is correct actually. E1 minus E2 is equal to h cut pi by t. Okay, h cut can be written as h by 2 pi into pi into t. T is actually what? Here, capital T actually. It should be capital T, sorry, in time t. It's okay, same thing. So I will put here capital T. So capital T. So pi cancel out. The answer is what? So the energy difference is h by 2t. Is it clear? This is the energy difference. Okay, h by 2t. Next question. This was a number question number 7. Question number 7. Question number 8. Consider a quantum particle of mass m in one dimension in an infinite potential well in an infinite potential well. Okay, that is Vx is equal to 0 for minus a by 2 x a by 2 infinite for x greater than equal to a by 2, like infinite otherwise, right? So a small perturbation small perturbation v dash x is equal to 2 epsilon mod x by a is added. So the change in the ground state energy is dash option A epsilon by 2 pi square minus 4. Option B epsilon by 2 pi square plus 4. Option C epsilon pi square by 2 pi square plus 4. Option D epsilon pi square by 2 pi square minus 4. Okay, so these are the question options. Potential is given, perturbation is given, we added change in the ground state energy. Okay, so how to do it? Perturbation is like ground energy correction is what? Expectation value of perturbation, right? So here expect value of perturbation is given here as 2 epsilon x by a. So here it is between what? Minus a by 2 to perturbation is like potential is between minus a by 2 to a by 2. So we can do the integration minus a by 2 to a by 2. This is a what? This is a 1D infinite potential well, right? 1D infinite potential well wave function is root over of 2 by a cos pi x by a, because it's a ground state. So cos pi x by a. Okay. Why I wrote this? So root over of 2 by a cos pi x by a, then 2 epsilon naught mod x by a, again root over of 2 by a cos pi x by a dx. So root over 2 by a, 2 by a going to outside. This 2 by a, 2 epsilon by a also going to outside into 2 by a. This is minus a by 2 to a by 2. Whatever is left, mod x cos square pi x by a. Okay, now see, this is mod x. We know what is mod x. Mod x definition is mod x is equal to x if x greater than 0, minus x if x is less than 0. So we have to divide the this limit also. So this will be your 4 epsilon by a square minus a by 2 to 0. Between this, what will be the value of mod x? Minus x, because it is less than 0. So minus x cos square pi x by a dx plus 0 to a by 2 x. It will be positive x cos square pi x by a dx. Okay. So if you see, this will be 4 epsilon by a square, and minus comes out, minus a by 2 to 0 x cos square pi x by a dx plus 0 to a by 2 x cos square pi x by a dx. Okay, yeah, is that all right? We can do one thing here. We can put x is equal to minus t. Okay, just for change of this thing. So dx will be minus dt, and limit will change. Minus a by 2 will change to a by 2. 0 will be 0. So if I change it now, 4 epsilon by a square, just for simplicity, see, minus of a by 2 to 0, x is minus t cos square pi x by pi t by a, yeah, same thing. Dx is minus dt, 0 to pi a by 2 x cos square pi x by a dx. Now see, minus minus plus, this minus still there, this becomes plus, right? Minus minus becomes plus, and if you see, this minus will exchange the limit, right? Isn't it? So 0 to a by 2 t cos square pi t by a dt plus 0 to a by 2 x cos square pi x by a dx. See, I am doing this just for your understanding. You can skip so many steps. Okay. 4 epsilon by a square. See, inside it I can change the variables. It's the same thing. So 0 to a by 2 x cos square. You may ask me now, sir, you have taken t, x is minus t. No, no, no. Here we can change the variable inside. Okay. 0 to a by 2 x cos square pi x by a dx. See, x dx 0 to anything is equal to y dy, 0 to anything is equal to t dt. So same variables we can change inside. So if you see, these two are equal, so 4 epsilon by a square to 0 to a by 2 x cos square pi x by a dx. Now the integration of it. What is the integration? We know cos square is how much? 4 epsilon by a square. 2 comes out. Integration 0 by a by 2 x. What is cos square? 1 plus cos 2 pi x by a whole divided by 2. I will take that 2 outside dx. Okay. So this can be 4 epsilon by a square 0 to a by 2 x dx plus 0 to a by 2 x cos 2 pi x by a dx. Okay. 4 epsilon by a square. This is your x square by 2, 0 to a by 2. Okay. Plus this integration I have to do by parts. It will be x into sine 2 pi x by a by 2 pi by a minus x is dx by dx is 1 minus sin cos. So plus cos 2 pi x by a. You have to do it fast, okay, yourself. This much. And yeah, this is right. Yeah, 0 to a by 2. So now 4 epsilon by a square. On this one, put the value a square by 4 by 2. That is a square by 8 plus. This is sine. If you put a by 2 here, a by 2 will become sine pi will giving me 0. So this term becomes 0. Only this term is left. Cos pi is minus 1. Minus 1. This is the what? Okay. If I see this term is your minus 1 by 2 pi by a minus, if I put 0 here, it will be cos 1. Like the value will be 1. So 1 by 2 pi by a. Okay. So that will be 4 epsilon by a square. A square by 8 plus minus 2 pi minus a by 2 pi minus a by 2 pi. Okay. So if you see, this is 4 epsilon by a square by 8 is minus a by pi. Okay. So if you just do this, if you do this, okay, no, it's right, it's right. So that will be a square will be cancelled. 4 epsilon by a square into a square by 8 minus 4 epsilon by a square into a by pi. Okay, a square so cancel out. This is 2 epsilon by 2 minus this is a 4 epsilon by a pi. Okay, is that right? Okay, this will be the answer, right? Yeah, yeah. Right. So these were some of the questions we did today. I hope you understood. Please let me know in the comments if there is any doubt, and you can ask me in the Telegram group also. All right. Okay. Thank you very much for watching.